The disk method. The disk method is used to evaluate the volume of an object revolved around the x or y axis. This is done by adding a bunch of tiny rectangular disks together at once. A disk is a cylinder. The volume formula for a cylinder is pi r squared times h. H is the same thing as delta x, and in this instance we're taking the limit of delta x as it goes to 0, and so we can throw that right out. What we're left is with pi r squared. The radius of the disk is the distance between the axis and the point on the function. And so if you're revolving around the x-axis, in terms of x, the integral of the function would be the radius of the disk. Revolving around the vertical axis is the same thing, except we take the function and put it in terms of dy. That means the disk's volume is equal to pi times the integral of the function squared in dy. The boundaries of each integral from a to b or c to d is where the area of the object we are rotating starts and ends. The washer method is used when the axis of rotation is not an axis itself. Similar to finding the cross-sectional area of two functions, we will take the volume of the bigger disk and subtract it from the volume of the smaller disk. This creates a washer. Essentially, we're performing the disk method for each function.
So in this problem, it asks us to find the volume of the solid generated when r is rotated about the x-axis. We know that r is the graph of y equals 20 over 1 plus x and the horizontal line of y equals 2. The first step is to graph the problem on your graphing calculator, as I have done to the left. The next step was to be to find the intersection points so you can know what bounds to do on your integral. You can use the intersection feature on your calculator to find these points, and they are at -3, 2 and 3, 2. Now, because we're rotating about the x-axis, and the x-axis is not one of the bounds, we have to use the washer method. So the final step is to plug the values into your equation, and because we're using the disk and washer method, pi is going to be outside the integral, and we're going to do the integral of -3 to 3 times the outer line, which is 20 over 1 plus x, square that minus the closer line, which is 2. And we get 1,871.190 as our final answer.
In this problem, the region which we are paying attention to is not bounded by any axis. That means we must use the washer method. Step 1 is to find the points of intersection. That way we can find out where this area starts and ends. Using our calculator, we found out that the area starts at 0.178, 0.781 and ends at 1, 0.25. Because we're revolving around the line y equals -1, which is a horizontal line, the washer method integrals in terms of dx. Beginning at point x, the graph of 1/4 plus sine of pi x plus 1 is on top of the graph of 4 to the -x plus 1. That means that one must come first in our washer method formula. We will take the first equation, square it, and subtract it by the second equation squared. Putting pi on the outside and then evaluating the integral, we found out that the volume of the shape revolved around y equals -1 is 4.558.
The first example is from the 2003 Free Response Question 1, Part B. The question says, let R be the shaded region bounded by the graphs of y equals root x and y equals e to the -3x, and the vertical line x equals 1, as shown in the figure. Part B says find the volume of the solid generated when R is revolved about the horizontal line y equals 1. So the first step is to find the intersection point of the two lines. So you can see that clearly at point TS. T is equal to 0.239 and S is equal to 0.489. Next, you determine that you use the washer method because the axis of rotation shown is not one of the bounds. After doing the washer method, you get an answer of 0.453 pi or 1.423.